whole number bases. But there is one that we do need to talk about. It's called base E. Base E, we have not necessarily letters that we use for numbers sometimes, right? Like pi. Pi is a number. Pi is 3.14, we usually say, but it's 3.1415, blah, blah. It keeps going. It's a number. Pi is a number. E is like that too, but it's not 3.14. Turns out E is a number. It's 2.71828, and then the next ones are 1828. So it kind of looks like it's starting to repeat. However, the next ones are 459, and it's a never-ending number like pi. That's what E equals. And it turns out that's not a randomly assigned number. That is a naturally occurring number, kind of like pi is. But actually, E is called the natural base. Because, like I said, it's a naturally occurring number, and it occurs in a lot of places. It's called the natural base. It's just like pi. It's equal to this number right here. Now, approximately, if your calculator has an E button, and we'll do that in just a second, but approximately E is what, 2.72? It's about 2.72. Pi, we say, is 3.14. E is about 2.72 or 2.7. But that's rounding it. It continues on. It's an irrational number. Okay. All right, so what do we do with it? Well, we're going to use it, like I said, for the base of our numbers. We're going to do numbers like e squared, e to the third, e to the negative. How do we compute it? Well, you could round it, but the calculators do a much better job for us. So yeah, we're just going to punch those in our calculator. See if you can find your E number on there, if you have your calculator. I may not be able to find it on this one. Here's pi. Oh, there it is. Okay, I found mine. If you can't find yours, just let me know. All right, so I'm going to do e squared, so I'm going to do that. Okay, e squared. So anybody got it? And mine is going to have to do this. 2 point. Okay. Figured it out. All right, there we go. 7.389, yes. Mine goes out to 0.6, but that would keep on going. If you need more, we could get it. But all right, with me there. So yeah, you just punch it in like you do any other base there. Can I do that one? Yeah, it doesn't have to be a whole number, and it even can be a negative number. You can do a decimal e. You just punch it in. E to the negative 1.8. Say if you have trouble doing it, just let me know. But I get 0.165299. How many ever places you need. Okay? All right, so the other angle to this is what are we going to do with that? Well, we can get some pretty complicated functions using base E. See here, this is base E. And so, which one's the variable? X is still a variable. E is not a variable. E is a number, just like pi is. So don't let that fool you. This is just, the function is e to the 2x. The x is the variable. So what we can do, one of the things they'll have you do is evaluate that if x is whatever you want to, 5.7. What do we do there? Plug in x to be 5.7. So it'd be e to the 2 times 5.7, right? We haven't done those, but that means 2 times x, so it'd be e to the 2 times 5.7, so it'd be e to the, what's that, 11.4? 2 times 5.7? Yeah, so you just punch in e to the e to the 11.4. Is that okay? I lost my e button. There it is. E to the 11.4. I get, ooh, big number, 89,321. Oh, that's rounded. Rounded off to that. Yeah, 7233 keeps going. And it may say round off to the nearest hundredth or whatever, but okay. All right. Well, since that is what it is, then we can graph this, can't we? What does this look like? What does the graph of that look like? E to the x. Well, isn't that one of these exponential functions? Got your variable and your exponent. And so that's our hockey stick, isn't it? Which way? Well, that's a base bigger than 1, so it's the increasing, right? The increasing type. And, you know, no shift on it, so yeah, we can just use our old standard -2 to +2 here. Graph this thing out. All right, so we got e to the -2. Don't know what that is right offhand, but I can get it pretty easily here. E to the -2, 0.135. E to the -1, well, it's 0.367. E to the 0, now I can do that one, it's 1. E to the 1, well, that's 2.72, since that's just e. And then e squared, we did that one a little bit earlier there. Don't remember what it was, though. 7.38? 39, okay. All right, so yeah, there we go. We should see then our nice increasing hockey stick here. -1, -2, 1, 2, 3, 4, 5, 6, 7. All right, e -2, I'm at 0.135. -1, I'm at 0.367. 0, I'm at 1. 1, I'm at 2.72. And then 2, I'm at 7.39, so something like that. So yeah, there you go. Now what happens on this end? Levels off, doesn't it? So we got the horizontal asymptote is y equals 0. Okay, what about e to the minus x? Well, it's going to work the same as those others. It's got the minus x, so it's the decreasing hockey stick shape, and your table should bear that out. -2 to +2. We have e to the -2, so that's e to the +2, so that's our 7.39. When x is -1, we have e to the -1, so that's e to the +1, that's 2.72. E to the 0, so that's 1. E to the -1, so that's the 0.367 at 1. At x is 2, we'll have e to the -2, which is 0.135. Yeah, things just, everything's just flip-flopped around, hasn't it? -2, I'm at 7.39. -1, I'm at 2.72. 0, 1. 1.367 to 1.35. Yeah. So it works the same way. Okay? All right. So let's do one more of those, and we'll talk about an application of this X natural base, or and others. Let's say, all right, so what would happen if I wanted to graph f of x equals e to the x minus 3 and then minus 2. What's that we're going to look at? Well, it is e to the x. And so that's the one looking like that. But I've got some shifting going on. I've got a minus 3 up here, and I've got a minus 2 down here. What does the minus 3 up here do? That's going to move it right or left. Minus 3 goes to the right. So that's going to take it 3 to the right. Minus 2 being in the outside. Shift 3 to the right. That's going to take it down 2, isn't it? So this graph, what we have is 3 to the right and then down 2. Well, if I move it down 2, what is that going to affect over here on the graph? Isn't that going to take the asymptote down 2? Yeah, so this moves the asymptote down 2, well, all the other points, but in particular it moves the asymptote down to B. So the horizontal asymptote would be negative 2. Instead of 0, it's now at negative 2, isn't it? Remember, the right or left shift doesn't change that horizontal asymptote, but the asymptote moving down 2 moves that. Okay, so we should see that. Okay, now, what the 3 to the right, my suggestion is, for the 3 to the right here, let's take our x values. The down doesn't, remember that's going to change kind of the y values, but the right and left kind of change the x values, if you will. So let's move our x values 3 to the right. Which would mean, instead of negative 2, if I go 3 to the right from that, where would that be? 1, 2, 3, at 1. So let's start at 1 and then go 2, 3, 4, 5. You with me? Shift those 3. That'll help out a little bit. You can do the others, but that would be a pretty good suggestion, I think. All right. So if x is 1, we have y is e to the 1 minus 3 minus 2. So that's e to the minus 2 minus 2, which, just plug that in. See, e to the minus 2 minus 2. It's negative 1.86. So at 1, I'm at negative 1.86. At x is 2, we'll have e to the 2 minus 3 minus 2. That's e to the minus 1 minus 2. Which mine says negative 1.63. At x is 3, I'll have e to the 0, right, minus 2, which is 1 minus 2, which is negative 1. At x is 4, I'll have e to the 4 minus 3 minus 2, which is e to the 1 minus 2, which is basically 0.72. And then x is 5, well, e to the e squared minus 2, which is your 7.89 minus, so it would be 589, I think. Checking on that. Is that okay? No, 5.39. Off a little bit. Okay, so graphing those, 1, negative 1.86. 2 is negative 1.63. 3, I'm at negative 1. 4, I'm at 0.72. And 5, I'm at 539. down. So there's our horizontal asymptote, like we said, at -2. Okay? All right. So as far as graphing, that's the basics of it. However, I did want to mention we are going to look at some applications here of exponentials and others along the way, but